Today we're going to be working on our Gizmo relative humidity investigation. Last week we were reading all about water in the atmosphere and how water in the atmosphere goes through the water cycle. So we're going to focus in on moisture in the atmosphere and something called relative humidity. So our learning target for today says I can use a sling psychrometer, collect data, and analyze the data to determine the relative humidity of the atmosphere. So to start by this assignment, you want to follow your instructions. So we're going to download the attached document, open it in Notability. That document is this one right here, relative humidity. And then we're going to log into Gizmos. Okay. So the document you're going to download is going to look like this. And to get into Gizmos, remember what you're going to do is you're going to click on the Gizmo login link. And you'll click on the login button in the top right corner and you just type in your username and password. If you don't have a Gizmo account, we set these up about 2 weeks ago. You can send your science teacher a message and they will help you get one set up. Okay. So click pause, go ahead and download the document, log into your Gizmo account, and when you're ready, click play again. All right, so we're going to start off with a prior knowledge question to kind of link this lab to what we're going to be learning about. So it says when you go outside on a hot summer day, usually your body begins to sweat. Why does your body do this? So I want you to think about what causes your body to sweat. When do you actually start sweating? And then you would write that response on the line right here. Okay, the next part says humidity is the amount of moisture in the air. Do you think sweating cools you down more on a dry day or a humid day? So I want you to think about, when do you sweat more? Do you sweat more on a humid day or a dry day? And when do you think it would cool you down more? Okay, I'm just going to write this down here so there's some room. So you would say either a dry day or a humid day. That's what would go in this blank. I didn't write it right here because it kind of is formatted weird. Then it says Gizmo warm up. When sweat evaporates, heat energy is removed from our skin and our bodies cool down, but the amount of water vapor air can hold is limited, so sweat can only evaporate if the air still has the capacity to hold more water. If the humidity is high, less water can evaporate from the sweat on your skin. The amount of water vapor in the air compared to the maximum amount of air can hold is known as relative humidity. In the relative humidity gizmo, you'll use a psychrometer to determine the relative humidity. A psychrometer has two thermometers. The dry bulb thermometer measures air temperature, and the second thermometer has a wet bulb. As water evaporates from the wet bulb, its temperature decreases relative to the air temperature. So this is our sling psychrometer. It's basically two thermometers that are connected together, and you spin it around like a helicopter. This one is called the dry bulb right here, and that's just a thermometer. Then you have a wet bulb that has a piece of cloth that's wetted down with water, and you spin both of those around for a minute or so, and then you check the temperature after you do that. So it says, do you think the wet bulb will cool down more on a dry or a humid day? So you have to make a prediction here. Do you think this thermometer, will it decrease in temperature more on a dry or a humid day? So again, you would just say what you think. Do you think it would be a dry or a humid day? So you pick one, dry or humid day. And you're going to pick one. You're making a prediction. All right, now it says click play and observe the thermometers for about 24 simulated hours. Describe some of the changes in temperature for both thermometers. So to set our gizmo up, you'll log into your gizmo and you'll click on the one that's called relative humidity. And we're going to just watch these temperatures for the thermometer, the dry bulb thermometer and the wet bulb thermometer. And so the temperatures are shown right here. So let's just watch those. Let's see what happens. We'll go through 24 hours. So we'll go all the way back to 3 a.m. That was our starting time. So you can see right now, both the temperatures are going up. And we'll just wait here for a moment until we get back to 3 a.m. We'll see what happens. Temperatures are still going up. And now it looks like they're starting to go down. Okay, so it looks like the thermometer, the temperatures went up on both of them. And now they're starting to go down. Okay, so if we were going to record in here, we could write down what happens. I'm just going to click down here. Actually, I'm not. So we could say that the temperature increased and then decreased over time. Okay, so we're going to say the temperature increased and then decreased over time because we saw that happen. All right, that would make sense that the thermometer is getting warmer as the day heated up and then it cooled off as nighttime occurred, right? All right, so click play or click pause on the video. Go ahead and try that, what we just did, and then record your answer and then click play again when you're ready to continue. All right, so now we come to the actual lab. When we do a gizmo, we always start by setting up the gizmo like it shows. So it says click new. I'm going to click new. Turn on show relative humidity. Remember, relative humidity is the amount of moisture in the air compared to the actual temperature. So we're going to make a prediction. It says, how can you use a psychrometer to measure relative humidity? Predict, how will relative humidity relate to the temperature of the wet bulb thermometer? So it's saying, how do you think the humidity will relate to this temperature? So for example, when the temperature is higher, do you think it will be more humid out? Or do you think when it's lower, it'll be more humid out? Okay, so we're going to make a prediction. So we can say something like, as the temperature of the wet bulb thermometer decreases, the humidity will, and you have to pick. Do you think it's going to decrease or increase? I want you to pick one. So as this temperature drops, what do you think is going to be happening to the humidity in the atmosphere? Do you think that's going to tell us that there's more moisture and water vapor in the atmosphere or less? So you can't get this one wrong. It's just a prediction. So go ahead and click pause on the video. Think about what your prediction is, write it down, and then click play on the video when you're ready to go again. All right, so now we're actually going to start to record some of our data. It says gather data. Click play and click pause at several random times. Record the dry bulb temperature, the wet bulb temperature, and the relative humidity. So we're going to click reset, and here's our relative. Click new, right? And here's our relative humidity. And let's actually just start with our starting one here, okay? So let's write down the dry bulb temperature. That's this one right here, and it's 22.1. And then the wet bulb temperature is 15.9. And the relative humidity, it says, is 52%. Now I'm going to click play, and we'll stop it here in a little bit. So you can see the relative humidity is going up. I'm going to stop it, okay? And I want to show you one more thing. So this is a picture of what the air looks like right now. This rectangle represents the total amount of space in the air, and the blue circles represent the space in the air that's filled by water, and the gray circles represent unfilled airspace. Okay, so right now the relative humidity is 67%. That means 67% of this rectangle is full of water, and the rest is open space. Okay, so let's write down what we have now. The dry bulb temperature was 16.2. And our wet bulb temperature is 12.7. And the relative humidity, it says, is 67%. So look what just happened here. It looks like the wet bulb temperature went down, and now the relative humidity went up. Okay, also looks like the dry bulb temperature went down, and the relative humidity went up. So it says, what patterns do you notice? All right, let's try one more. So I'm going to click play here and get a little more data. Okay, so this time it looks like the temperature was, dry bulb was 20.2 and the wet bulb was 14.9, and it looks like our relative humidity went down. Okay, let's try one more time here. Okay, so this time it was 22.3 and 16, and the relative humidity is 52. Okay, so what patterns do I notice here? Well, if I look at these last two trials that I did, when the wet bulb temperature was 14.9, the relative humidity was 56%. When the wet bulb temperature was 16, so that's higher, the relative humidity was 52%. Okay, so the patterns that I see when I look at the wet bulb temperature, when it was 14.9, the humidity was 56. When it went up a little bit, the humidity went down. So the pattern I'm seeing is that as the wet bulb temperature goes up, the relative humidity decreases. All right, we're going to keep going here. So now it says measure. Select the table tab. So we're going to select table over here. And it says this table will help you determine the relative humidity. Click play and then pause. What is the dry bulb temperature? So we're going to hit new, click play, and then pause. So our dry bulb temperature is 21.8. And then it says, what's the wet bulb temperature? 17.8. What's the difference between the dry bulb and the wet bulb temperature? So the difference is going to be this number subtracted our small number. So I'm going to do 21.8 minus 17.8. So that's going to be 4. Okay, so this number, everybody, is called the wet bulb depression. So when you do this in real life, if you didn't have a digital sling psychrometer, you have to find out how much the wet bulb temperature decreased compared to the dry bulb. Remember that wet bulb temperature is always going to be lower because water is going to evaporate off of that wet cloth and it's going to cool down this thermometer compared to that one. So we're going to use a sling psychrometer table to help us find out what the actual relative humidity is. So what we do is we follow directions. It says find the dry bulb temperature on the table's left column. So our dry bulb temperature was 21. So this is the left-hand column. So I'm going to go down to right here. We'll call it, it was 21.8. So we'll round up, we'll call it 22. And then it says use the drop-down menu to see the different temperature differences. So our temperature difference, remember, wet bulb depression was 4, so that means I have to choose which table I'm going to use, and that would be this one, right? Because anything from 1 to 5 degrees difference. So since it's only 4, I'd use this top one. So then I'm going to find my 22 again, and then it says The relative humidity is found at the intersection of this row and the column. Okay, so my dry bulb temperature is 22. So I go over, and it makes an L, and I go up to where that's my wet bulb depression, the difference between the dry bulb and the wet bulb. So I go down, I find the 4, and I go down to where it meets 22. So my relative humidity would be 68 degrees, 68, okay? So it's 68. And again, this is how we would do it in real life if we weren't doing this in a simulation. We'd have to use a table like this to figure out what the relative humidity is. All right, so click pause on your video, go ahead and complete this step, and then click play when you're ready to go on. All right, so we're gonna do some more practice with using this table. So it says practice, select the table tab again, click play and click pause at several random times. Each time record the dry bulb temperature, the wet bulb temperature, and the wet bulb depression, and the relative humidity. So we're gonna do the same thing that we did, but we're gonna get a little bit more data. So I'm gonna hit play here. And hit pause. All right, so I'm gonna write down my dry bulb temp was 23.1. And my wet bulb temp was 18.8. Wet bulb depression, remember that's going to be the difference between the dry bulb temperature and the wet bulb. So I'm going to subtract these two numbers. I'm going to do 23.1 minus 18.8. And it's okay if you want to use a calculator, you can for this. 23.1 minus 18.8. So I get about 4.3. So to find the relative humidity, I got to go back to my table. First thing is I look at which table I'm going to use. So my temperature difference is about 4, so I'd still use this 1 to 5 degrees table because it's between 1 and 5. And then I would find my dry bulb temperature, which is 23. So I'll go down. And you know what? I don't see 23, so I'm just going to kind of estimate in the middle. So it's closer to be right about in the middle here. Okay, so I'll just use the 22. So I'm going to go over to where it reaches the 4. And see, it's right here, but we know that 23 is kind of halfway between 24 and 23, right? So if 24 would be 69, 22 at 68, so it'd be kind of right in the middle. So we can just estimate it'd be about 68.5. Doesn't have to be perfect. Let's try it again. So I'm gonna get some new data here. And you can see my temperatures are going up. All right, so let's let that go a little bit longer. Now they're going down. Okay, so we'll do this one. So we have dry bulb of 19.8 and wet bulb of 16.3. And then the depression, that'd be the difference between them. So I'd subtract 19.8 minus 16.3. So it'd be about 3.5. And so my humidity would be, I'd have to find, basically this is going to be 20. So I'll go down to 20. So I go down to 20. And I have a difference of 3.5. So it'd be right about, here's 3. So it'd be between kind of 74 and 66, right? So it would be probably about, so I go, we'll just call it 20 and go up to 3. It'd be about 75. But in reality, it would be a little bit more over. So it would be between 74 and 66. So we call it about, probably about 70. Okay. Try one more here. All right, so now the temperature's dropped and our dry bulb temperature is about 11.8 and the wet bulb temperature is 10.3. And so the depression would be 11.8 minus, so I'd have about 1.5 here. And so let's figure out what this was. So this was about 12. So I'd go find my dry bulb. So I'd go to 12 right here. And the wet bulb and the depression was 1.5. So I would go over. So right here would be 1. So it'd be between 89 and 78, right? So it would be about, probably right up on the middle, about 83, 84 or so, right? Okay, so I go over, down 12, over to 1, so it'd be 89. But since this depression is a little bit bigger than 1, it'd be kind of halfway between here. So it'd be between 78 and 89, so probably about 83, 84, right? When you keep in mind, you guys, when you're collecting your data is going to look a lot different than mine. It depends on what time you stop it at. The important thing is that you're writing down the dry bulb temp, the wet bulb temp, the wet bulb depression. Remember, that's the difference. You subtract these two columns. And then the relative humidity is you use this chart and you find the dry bulb and you go down to whatever your dry bulb temperature is, and then you go over to whatever the difference, the wet bulb depression is, the difference is, and you make a L, and where those two connect, that's your temperature, okay? All right, so go ahead and click pause, take some time, and fill this data table in, and when you're ready, click play again. All right, we're back. Now it says examine the psychrometer table on the table tab. As the wet bulb depression increases, what happens to the relative humidity? So it's asking about this column. It's saying what happens when the wet bulb depression gets bigger. That means there's a greater difference between the dry bulb and the wet bulb. Well, look at it. When it was 1.5, the humidity was 83. When it was 3.5, the humidity was 70. And now the biggest one we measured, the humidity was 68. So it looks like when the wet bulb gets bigger, that means the depression gets bigger. That means the humidity is less. And that makes sense because more water is evaporating and cooling down the wet bulb more. Okay, so we can say as the wet bulb depression increases, the humidity, say the relative humidity, decreases. As the wet bulb depression increases, the relative humidity decreases. And that makes sense. The bigger the gap we have is caused by the fact that more water evaporated off the wet bulb, which means there's more space in the atmosphere, so the relative humidity is less. It says that the dry bulb temperature increases with a constant temperature difference. What happens to the relative humidity? Well, let's look at our table here. So we had a cold temperature here, kind of in the middle, and a high temperature here. So it looks like when the dry bulb temperature went up, the relative humidity looks like it went down. So what we can write is we can say make this red so you can see it. Say the relative humidity decreases. And then it says, how do you think the amount of water vapor air can hold changes as air temperature increases? Well, when we look at the last question, remember when the dry bulb temperature went up, so when the air temperature got warmer, the relative humidity went down. And what does that mean? It means that there's more space in the air for water vapor to be held. So the percentage of the air that's full of water is not as much, and that's why it went down. And it makes sense because when the temperature of the air is warmer, the air molecules are going to spread further apart, and that creates more space for water molecules to be held in the air. When it's colder, the air molecules move closer together, and there's not as much space for more water molecules to be held, okay? So how do you think the amount of water vapor the air can hold changes as the air temperature increases? So we can say the amount of water vapor the air can hold increases. Okay, so the amount of water vapor the amount of water vapor the air can hold increases. All right, this last question says, think about it. Warm air is able to hold much more water vapor than cold air before it becomes saturated. How would you expect the relative humidity of air to change as air warms up in the morning? How would you expect it to change as air cools in the evening? So another thing you guys can do is you can click on your simulation and you can click show air sample. So let's just start again here. And right now the temperature of the air is 15.9 degrees Celsius. And you can see that we have a relative humidity of 33%. So this rectangle is showing you the total amount of space in the air. The blue circles represent the space that's held by water, and the gray circles represent the open space. So let's watch what happens when the temperature increases. So right now it's going down, but let's see what happens. So as it's going down, you can see the relative humidity is increasing because now there's not as much space. But let's watch what happens when temperature goes back up here again. Just wait for a sec. All right, so we were at 15, so let's see what it does once it gets past 15. So you can see as it got up to 17, you can see the relative humidity went down even more. And that's because look at all of this open space. When the temperature of the air is warmer, there's going to be more open space for those water molecules. So I want you guys to use everything you learned in this lab, what you record in the data tables, and what you've experienced in the simulation to answer this question. So we are going to be going through this lab in our connections this week. So please don't feel overwhelmed. Come to our connection and we'll work through this together if you're having trouble. Have a great day.